Okay, so this is chapter 6, number 41. The directions say, the pattern of growth varies from child to child, so we can best understand the general pattern by following the average height of the number of children. The table on page 390 represents the mean heights of a group of children in Kalama, an Egyptian village that was the site of a study of nutrition in developing countries. The data were obtained by measuring the heights of 161 children from the village each month from 18 to 29 months of age. So A says, make a scatter plot that describes the relationship between age and height, and to describe what you see. So to make a scatter plot, we're going to use our calculators. So first, you need to press Stat, then you press 1, Edit. In list 1, we're going to put in all of our x values. Now we're going to do the same thing for list 2, but we're going to put in all the y values, which are in the column height y in centimeters. Once you're done, press second and press the y equals button, which is a stat plot button, to make sure that your plot 1 is on. Once it's on, press zoom and scroll down to number 9, which says zoom stat. Press enter. Your graph will appear on your calculator screen and the points should look like a semi-straight line. Now to answer A, you can conclude that there's a strong, positive, linear relationship between age and height. So for B, it says, use your calculator to obtain the least squares regression line. Interpret the slope and y-intercept in this setting. So since your data is already plugged in the calculator, press Stat, then scroll down to Calc, and press Enter. Then scroll down to 8, which is linear regression, which has the parentheses a plus bx, and press Enter again. The x list should be L1, which is list 1. The y list should be L2, which is list 2. Then the store regular equation, press vars, then scroll to the right to y vars, and press 1, which is function, and the y1, and calculate it. The regression line equation is y equals a plus bx. So with what the calculator tells you, you can fill in the equation. So the equation is y equals 64.928 plus 0.6350x. The slope is 0.6350, which means that the regression line goes up a positive 0.6350 centimeters and goes to the right a positive 1. The y-intercept tells us that the regression line intercepts the y-axis at 0,64.928, or in other words, at a 0-month-old would be 64.298 centimeters tall. Now for C. C says, predict the mean height of Kalama children at 32 months of age. How confident are you in the accuracy of this prediction? Explain! So to answer this question, you will have to plug in 32 into the least squares regression line equation you found in B. So you say that y equals 64.928 plus 0.6350 times 32. That equals out to 85.248 centimeters. Then, to answer C, you can say that you are confident that your prediction of the height of Kalama children at 32 months of age to be about 85.2 centimeters, because the data shows us that as the age increases, so does the height, which also tells us that there is a strong linear relationship. Now for D, it says, predict the mean height of Kalama residents at 20 years, or 240 months. How confident are you in the accuracy of this prediction? Explain. So to do this problem, you are going to do the same steps you did in C, but instead of 32 months, you are going to plug in 240 months into the equation. So y equals 64.928 plus 0.6350 times 240. That ends up being 214.928 centimeters. Then you can conclude that you are not confident in the prediction of the children because we are predicting over the range of the data given, and 214.29 centimeters is over 7 feet tall. That is to conclude this problem. Goodbye.